Hi, Heron and Riverside High School students. Today we're going to be talking about temperature, heat, and kinetic energy. And hopefully these words look familiar, as this is something that we've talked about in the past as well as in physics class. So to start off with, we're going to start off with some review and think about how do molecules move in terms of speed at solid, liquid, and gas temperatures. So solid, they move pretty slowly, they just vibrate little by little. So I'm drawing little arrows. But then liquid, they move faster. And gas, they move fastest. In all different directions. Keep that in mind as we talk about kinetic energy today. If we look at water, or H2O, do you know what temperature water transfers from a solid to a liquid, or the melting point? Do you know when it goes from a liquid to a gas, the boiling point? It is 0 degrees Celsius to go from a solid to a liquid, and then it must be, or which is equal to 32 degrees Fahrenheit, and then to go from a liquid to a gas, or the boiling point, would be 100 degrees Celsius, which is equal to 212 degrees Fahrenheit. So if we look at these, we can talk about kinetic energy and determine which one has more kinetic energy. Going from a solid to a liquid or going from a liquid to a gas? Well, kinetic energy is the motion of molecules. So which molecules are moving fastest? At a solid, liquid, or gas? The answer would be gas. Because up here we looked and they're moving really fast. So therefore they have the most kinetic energy. We're next going to talk about what is temperature. Temperature is a measure of the average kinetic energy of a sample. So we're measuring how fast those molecules are moving. Temperature has a direct relationship with kinetic energy. So as temperature goes up, the average kinetic energy goes up. And we saw that because here our temperatures are increasing as we're going across, and therefore our molecules are moving faster, we have greater kinetic energy. If we look at the word thermometer, what words do we see in there? Well, thermo means heat or kinetic energy, and meter is our measurement of it. So therefore, when we use a thermometer or take the temperature of a sample, we are measuring the average kinetic energy of the sample. Now do something for me. Place your hand on an object that you think would feel cold. So right now, if I'm sitting at my kitchen table, I might feel a metal part of my chair, or maybe the metal of my computer. And then something that I think might feel warm. So maybe a piece of paper, maybe the wood on a table, or something else that you can think of. Do you think these two substances have the same temperature? Or would one be warmer and one be colder? So if I took an infrared thermometer and measured the kinetic energy, or measured the temperature, which is the average kinetic energy of the sample, I would find that those molecules are moving at the same speed. They're going to have the same temperature. So if my thermostat in my house is set at 70 degrees Fahrenheit, those molecules are both moving at the same speed. I would see that they both measure 70 degrees Fahrenheit. So when we touch something, we don't actually feel the temperature. We feel the rate at which heat is conducted or transferred towards or away from you. So if we think about sitting on a bath mat versus the tile on the floor, if you get out of the shower and are cold, you're probably going to want to stand on the bath mat. And that is because the bath mat conducts heat less quickly away from you than would the tile. So we're going to talk about the process of energy transfer. The energy that is transferred is called heat. Heat always transfers from hot surfaces to surfaces lacking heat. So in the example from standing on the tile versus the rug, the heat goes from the hot surface to the surface lacking heat. When the two objects reach the same temperature, they're said to be at thermal equilibrium. So they have the same temperature. And we can talk about the system and surroundings, which is maybe something you've heard in previous science classes, but the system is the process that you are focusing on. So maybe we're focusing on what's the heat in the campfire or the water in the beaker. Not necessarily the beaker, but the water inside it might be the system, and then the surroundings, everything outside the system. So for the campfire, maybe stuff surrounding the campfire, such as dirt, and then for the water in the beaker, maybe in the surrounding we also have a thermometer or the table, etc., etc. So with thermodynamics, we have a few laws, which you've probably heard before. We've talked about them as well as in physics. But the first law of thermodynamics is that heat is conserved. Energy cannot be created nor destroyed. It is only transferred from one object to another. So when your feet hit the tile in the bathroom, there is just a transfer of energy. And then the second law of thermodynamics is that energy tends to disperse. The universe is in an increasing state of disorder. Energy is absorbed by a substance as it warms up or boils. It's gaining energy, and then it's released from a substance when it cools down, condenses, or freezes. And now we're going to talk a little bit about the units behind temperature. So one unit is Fahrenheit, and Daniel Fahrenheit in 1724 created the Fahrenheit temperature scale. His scale did not have consistent references to anchor it. On his scale, 32 degrees Fahrenheit meant water froze, and 212 degrees Fahrenheit, water boiled. So just kind of two numbers that seem pretty random. But then, so that was 1724, but then several years later, Anders Celsius came around in 1747, and he used melting snow, and the boiling point of water was his reference, and set a scale from 0 degrees to 100 degrees Celsius. So it made things a little bit easier, especially in the science community. We're going to look at the thermometer on the right to help us answer these questions. A typical classroom is set to a temperature of 68 degrees Fahrenheit. If we look at this thermometer, what's the degrees in Celsius? Well, 68 degrees Fahrenheit is about here, so it would be 20 degrees Celsius. Anybody know what is the body temperature to be healthy? Anyone know? So it's about 37 degrees Celsius. And you might know this better from the temperature in Fahrenheit. But if I found 37 on here, it's about here. So maybe about like 95 degrees. And maybe you know one, or I think it's closer to 97. And maybe you know Fahrenheit better. And so then you might know that better. And it might be closer to like 98 or so. So we can convert from one to the other. Which would be hotter, 30 degrees Celsius or 30 degrees Fahrenheit? Why do you think so? So if we found 30 degrees Celsius and 30 degrees Fahrenheit on our thermometer, 30 degrees Fahrenheit would be about right here, and 30 degrees Celsius would be about right here. So 30 degrees Celsius would be warmer. And then if we looked at 50 degrees Celsius on our thermometer, it might be about 122 degrees Fahrenheit. We can determine that more closely, more accurate, by using a formula versus always relying on this thermometer. So check your calculation using this formula. Did you get the right answer? We're now going to take some time to do some practice using our formulas to convert from Fahrenheit to Celsius and Celsius to Fahrenheit. So if we wanted to convert 75 degrees Fahrenheit to Celsius. So we have Fahrenheit, we want to find Celsius. We're going to use the equation on the right. So we're going to rewrite it. I think it's always easier to rewrite our equation to start with. So C equals 5/9 F minus 32. So I plug in 75 degrees Fahrenheit in for where it says F. And then I can calculate it from there using my orders of operations. So 75 minus 32 is 43. And then I multiply that by 5/9, which gives me about 23.89 degrees Celsius. Don't forget your units, which is great because it wanted us to get in Celsius. And I could even look back at my thermometer, and 75 degrees Fahrenheit is about around here somewhere, which is around 30 degrees Celsius, or 23 degrees Celsius, I'm sorry. And then next, if we're converting from degrees Celsius to degrees Fahrenheit, we're going to use our other equation, which is just the opposite. So 9/5 times 15 plus 32. So 9/5 times 15 is 27 plus 32, which gives us 59 degrees Fahrenheit.